Algebra I 8.6c. This is an attendance and admission word problem. We've been doing word problems over the last couple of videos with systems of equations. So 578 people attended a concert, and the price of an adult ticket was $2, and a child's ticket was $1.50. The theater sold $985 worth of tickets. How many adults and how many children bought tickets to the concert? So we can write a system of equations to solve this. We're going to let A equal an adult ticket and C equal the child's ticket. Well, it said that 578 people attended, so that's how many tickets they sold. So the adult tickets plus child tickets equals the 578. It also said that the adult price was $2 and the child's was $1.50, and that they made $985. So we know that $2 for the adult and $1.5 for the child equals $985. Now, do you see what I did about the money? I took the 0.00 off the 2 here, and I took the 0 off the 50 and just made it 1.5. It's going to make it a lot easier, and I'll show you at the end, because I'll leave it on in the end and show you how it comes out. So we can multiply the first equation by a -2, this one by a -2 to make a 0 pair. So we take the A plus C equals 578, and we multiply each term by a -2, and we get -2A minus 2C equals -1,156. Now, we put this equation with this equation, because it's got a positive 2A and that's got a negative 2A, and that's going to create a 0 pair right here, and we can eliminate A. See? Now we have a -2C plus 1.5C. Well, that gives us a -0.5C. And on this side, when we have -1156 and we add 985, we get a -171. Now we can divide each side by the -0.5 coefficient here. And what we get is 342. So the child ticket total was 342. So now we can plug in the 342 into this first equation, A plus C equals 578. And there's the 342 in place of the C. A plus 342 equals 578. We take away 342 from each side, and we find out that the adult tickets were 236. So there were 236 adult tickets and 342 child tickets. When you add this together, it totals 578. Now we could have made a table. We could have put adult, child, and total, the number of tickets sold, A for adults, C for child, and then it totaled 578. The ticket price for adult was $2. The child price was $1.50. We leave that one blank. And the total dollar amount sold would be adult times the $2, however many adults times $2, and the total sold for children would be $1.50 times however many children. And that would total the $985 that they brought in, see? And that could help us solve it. Now, what would have happened if we kept it as money, like $2 and $1.50? So we could have removed the decimal point from the second equation by multiplying each term by 100. So we had $1.50. If we multiply it by 100, that moves that decimal place back 1, 2 to here, and now we have 150. And if we do it to each one of the terms, we have 200A plus 150C equals 98,500. Now see what happened, how this got so huge? By me keeping it at a 1.5, yeah, I had to deal with the decimal, but it kept the number smaller. And now I've got 98,500. Now we have to multiply the first equation. Instead of multiplying it by a -2, like we did down here to create a 0 pair with this 2A, in order to create a 0 pair with this equation, 200A, we've got to multiply it by -200A instead of -2. See? So now we've got -200A minus 200C equals -115,600. See? Because we multiplied it by 100, we got these extra zeros here. Now we can take the second equation and put them together, create a 0 pair here, and -200 plus 150 is -50C. And when we have -115,600 and we add 98,500, we get -17,100. When we divide each side by this negative 50 coefficient, that creates a 1 here, and negative 17,100 divided by negative 50 is a positive 342. That's the same number we got over here. See? We're just dealing with bigger numbers because we got rid of the decimal point that way. If you can remember to use a 1.5 for $1.50, that's going to help you, you know? Now, if it's like $1.52, yeah, then you're going to have to move the decimal point because there was $1.50 and there was a 0 in the ones place. I was able to just do 1.5. So now we just solved it the same way. We still get the children's tickets is 342 quantity, but we had to work with larger numbers. Now we can just plug it into the first equation and we still get the adults are 236. It's the same solution. So either way you want to do it is okay. You're going to get the correct answer. It's just when you get good at it, you can just use $1.50 as 1.5, can't you? All right, so remember to check to see if the answer makes the equation true. That's really important to make sure you did the math correctly. Remember to keep using the same unit of measure or value for the entire problem. If we're using dollars, we got to stick with dollars. If you're using inches, you got to stick with inches. And that we can multiply each term of one equation by a number that'll help us eliminate a variable with a zero pair. So we multiplied this one by a negative 200 because of that positive 200, so we could eliminate the a, see? Or a negative 2 to eliminate the a on this one, see? All right, our next video is going to be 9.1. We're going to go into chapter 9, and we're going to talk about set builder notation. If you want to see a link to the number of coins word problem or the sum of two digits word problem, or whether to use substitution or addition method, which is like elimination, or any of the previous videos that we just recently did, there'll be links in this one's description. And I'm also putting a link to my intro algebra word problem playlist because there's a lot of algebra word problems in that playlist that you could scan through the titles and see if one of them looks like it would be helpful to you, okay? It's a nice playlist to have on hand when you're doing algebra because you can refer to it and say, oh, that's how you do that kind of algebra word problem, all right? All right, I'll see you in chapter 9. Bye.